Okay, so we have these graphs drawn in our notebook. Now let's talk about what these can show us and what does it mean about these different locations if their temperature graphs have this shape. Well, look at this first location. Here we see in January, temperatures are way down here, down low. And it seems like, wow, they really go up high in July, in the summertime. And then as we go back towards December, it seems like they take a really steep, dramatic fall right back down towards winter. So this is a place where temperatures change a lot. And we can see that by the shape of the graph. It's a really tall, steep graph. So there's a lot of change going on from January to July and then back to December. Well, what kind of places change temperatures so much? Well, if you have a graph that has a shape like this, you gotta be far away from water. A place like an island or someplace on the coast, remember, if you're close to water, you just can't change temperatures that much. So this has got to be a place that's really far from the water. Like, I don't know, the middle of our country or the middle of Canada or the middle of Alaska. Someplace that's not an island and it's not near the coast. But there's something else about a place's location that will make it change temperatures a lot from winter to summer and back to winter again. Now, could this be a location at the equator where the sunlight is always directly overhead? Answer is no. You know, at the equator, your temperatures just don't change that much because you've always got a lot of sunlight. So, where does the amount of sunlight change a lot from winter to summer and winter again? Well, that's places that are far from the equator. So I'm looking at this thinking, not only is this someplace that must be far away from water, this must be someplace that's really far north. It's got to be away from the equator because places to the equator, closer to the equator, just don't change that much. Like this couldn't even be Florida because Florida doesn't change that much. It can't even be Georgia because we don't go that dramatic from winter to summer and back again. So the two conclusions we can make from this is must be someplace really far away from water and it must be really far north. So let's talk about some real places where their temperature graphs could look like this. North Dakota would be a good choice. Look where North Dakota is. It's way up here. It's way far north. It's almost in Canada. And it is really far away from any water. It's not near the Atlantic. It's not near the Pacific. It's not near the Gulf of Mexico. So a good example of a place like this would be North Dakota because it's way far away from the water and it's really far north. And that's the kind of place that would have a temperature graph that looks like this. Far away from water, really far north. So a place like North Dakota. Some places in central Canada. And like central Alaska. Now, Canada and Alaska, we gotta quantify that. We're talking about central Canada and central Alaska because those are places that have a coastline. If we look at Alaska, and this isn't drawn to scale, see there's some places around Alaska, it's all surrounded by water. But if you're in the middle of Alaska, you're so far away from the water that your temperatures can get pretty hot and then get really cold in the wintertime. Okay, so that's our first shape temperature graph. Now let's take a look at this one. What can we tell from this graph here? Okay, well, it kind of does the opposite. It really doesn't change much from January to July to December. Okay? If it doesn't change temperatures very much, it's probably close to the water, because we know that being close to the water means your temperatures are going to get really, really hot or really, really cold. They're not going to change much throughout the year. But look at these temperatures. We're kind of high on the temperature scale here, aren't we? So we've got hot temperatures that don't seem to change very much. So what part of the world has temperatures that stay hot all the time? This is probably someplace that's both close to the water and close to the equator, because the temperatures are always hot, like they are at the equator, and they don't change much from winter to summer to winter again. Now, some examples. This is what Hawaii's temperature graph looks like. Because they're an island surrounded by water, they just don't change much from summer to winter. And their temperatures are always pretty warm. And a lot of what we call tropical islands would have a temperature graph that looks like this. Islands in the Caribbean, exotic places like Fiji and Tahiti and all of these tropical type islands, they're going to have temperatures that look like that, or temperature graphs that look like that. Now let's take a look at this one. Now, here we got one that still doesn't seem to change too much. Changes a little bit more than the one we had before, but it has a little bit more of a change to it from winter to summer to winter again. Well, if it's not changing that much, it means it's got to be close to water. Because the only time you're going to get a shape of your graph like this, the only thing that's going to keep your temperatures changing from summer to winter is if you got a big body of water close by. Because that water is going to stay about the same temperature all the time. Now, this is a place that is probably far from the equator. Now, it's close to water, but it's far from the equator. Well, how do we know it's far from the equator? Because look where the temperatures are. The temperatures are cold. So you're talking about a place that doesn't get a whole lot of sunlight. Where are the places on our planet that don't get a lot of sunlight? Well, really far from the equator. So whereas the previous one was an island like Hawaii, which is down near the equator, this is more likely like an island in Alaska. So it's an island, so it's surrounded by water, but it's Alaska, so they don't get much sunlight. And the water's always going to be pretty chilly. So you're going to have a shape of your graph like this. Colder temperatures, because you're really far from the equator, but they don't change a whole lot because you're close to the water. Now let's take a look at this guy here. How was he different than some of the other graphs that we looked at? And those other places were kind of extreme, Hawaii, North Dakota, an island in Alaska. Notice this one's kind of in between. You have a change from winter to summer to winter again, but it's not way, way cold and then way, way hot and then way, way cold again. So it doesn't get as cold, doesn't necessarily get quite as hot, but there is a change of seasons. So some conclusions we can make from this. Well, is this a place that's close to the water? No. It's probably not really close to water, because if it were closer to the water on the coast, it'd be a lot flatter curve. Okay. Is it a place really far north? Probably not, because if it were really far north, you get a big change from winter to summer. Does it change from winter to summer? Yeah, a little bit, but not as crazy as the other ones did. Okay. Do you think it's really close to the equator? Well, it can't be really close to the equator, because if it were close to the equator, it would be hot all the time. Can it be really far from the equator? No, because if it was really far from the equator, it'd be pretty much be cold all the time. So this is a place that's kind of in the middle. We would say it's not close or far from the equator. Let's say kind of it's in the middle. So we wouldn't call it a northern location, but it's also not equatorial as well. Now, what I've drawn for you here is like us here in Georgia. Now, think about that. We're not a northern state, but we're not parked on the equator either. Well, we're not really far from the water like Nebraska. We have a coastline and we're really close to Florida, but it's not like we're right on top of the water either. We're not an island. So Georgia's temperature graph looks something like this, and a lot of places that are kind of in the middle. They're not real close to water. They're not real far. They're not really far north, and they're not really far south. Not when you think about the whole globe. So this would be like Georgia. The more north you go from Georgia, the more steep this graph gets. The more south you go from Georgia, the flatter this graph would get. Like Florida's graph would be a lot flatter than Georgia's. Whereas Tennessee, Kentucky, Ohio, theirs would be a little bit more steep and taller. So let's take a look at this guy here. First of all, is this a big changing graph? Yes, it's got a big curve to it. So it's definitely not close to the water, because if close to the water, it'd be flat. It's probably pretty far from the equator, because it's got a pretty significant difference between January to July. So if your sunlight's changing that much, changing your temperatures that much, you're this is not a place that's at the equator. It can't be, because it's not flat enough. Okay. Now, what's different about this graph? Look at their temperatures. Their temperatures are highest in January. They are lowest in July. That means we're getting the least sunlight in July, most sunlight in January. Well, we know that's not right for us here in Georgia. We get a lot more sunlight in July than we do in January. That's why our temperatures are highest in July and they're coldest in January, December, when that's our winter time. So what determination can we make about this place? If it's hottest in January and coldest in July, that means this place must be in the southern hemisphere. It's got to be, because remember, the southern hemisphere is backwards from the northern hemisphere. That when we are getting our greatest sunlight in July, they're getting their least, and their temperatures are lowest. When we're getting our least sunlight in January and December, they're getting their most, and their temperatures are highest. So a good example for this would be like central Australia. A big chunk of land. Australia is a big, huge island. So you can get far away from the water. And you're in the southern hemisphere. So you're going to have a big change in temperatures between seasons. So we have these in our notebook, and you're going to take these out and use these as a reference because I'm going to give you graphs and say, okay, which one of these graphs do you think could be an island in the Caribbean or mountains in central Canada? These are strictly to have for reference for you to look at.